There's a moment every summer when you unwrap that perfect ice cream bar, and for just a second, everything else disappears. The creamy texture, the burst of flavor, the satisfying cold against the heat. But have you ever stopped mid-bite and wondered, how does something this complex, this perfectly textured, this consistently delicious get made millions of times a day, exactly the same way, in factories around the world? Most people imagine ice cream production as some kind of oversized kitchen, with giant mixing bowls and industrial freezers. The reality is far more fascinating, and infinitely more precise. Behind the scenes of modern ice cream manufacturing lies a world of molecular engineering, temperature manipulation down to fractions of a degree, and production lines moving so fast that human hands would never keep pace. These facilities operate like precision laboratories crossed with high-speed assembly plants, where the difference between creamy perfection and icy disaster can be measured in seconds. The journey from raw milk to that frozen treat in your hand involves processes most consumers never imagine. Milk arrives by the tanker load, but it won't stay milk for long. It gets broken down, rebuilt, heated to temperatures that would scald your hand, then frozen faster than nature ever intended. Flavors get added not by the spoonful, but by the hundreds of gallons. Air itself becomes an ingredient, carefully measured and injected. Every chocolate chip, every swirl of caramel, every crunchy inclusion gets added by machines that never miss, never misplace, never break the rhythm. What you're about to discover isn't just how ice cream gets made. It's how modern food science has turned a simple frozen dessert into one of the most technologically sophisticated products in your freezer. The factories that produce it operate 24 hours a day, 7 days a week, creating thousands of gallons per hour with a level of consistency that would have seemed impossible just decades ago. Welcome inside the hidden world where chemistry, engineering, and culinary art collide at sub-zero temperatures. The ice cream industry produces over 15 billion liters annually worldwide, making it one of the most consumed frozen foods on the planet. But here's something that surprises most people. The ice cream you eat today bears almost no resemblance to what your grandparents enjoyed. Modern ice cream is an entirely different product, engineered at the molecular level for texture, stability, and shelf life that traditional recipes could never achieve. Consider this fascinating fact. Premium ice cream contains between 40 and 60% air by volume. That's not a defect or a cost-cutting measure. It's absolutely essential. Without that precisely measured air incorporation, called overrun in industry terms, ice cream would freeze into a dense, hard, nearly inedible block. The air creates the smooth, scoopable texture consumers expect. Too much air and you get a cheap, fluffy product that melts instantly. Too little and you create frozen dairy concrete. The factories that master this balance have spent decades perfecting the exact moment when air gets injected, how much gets added, and how to keep those tiny bubbles evenly distributed throughout millions of gallons. Temperature control in these facilities operates at a level most people can't fathom. During the pasteurization phase, milk gets heated to exactly 85 degrees Celsius, held there for precisely 15 seconds, then crashed back down to 4 degrees Celsius in less than a minute. This thermal shock kills dangerous bacteria while preserving the proteins and fats that give ice cream its structure. The equipment monitoring these temperatures measures in tenths of degrees, with automated systems that can detect and correct variations faster than any human operator could react. Here's something that blows people's minds. The chocolate chips in your ice cream aren't regular chocolate. They're specially formulated to remain solid at temperatures that would turn normal chocolate into a puddle. These inclusions contain modified fats and stabilizers that keep them intact even when surrounded by a product that's constantly cycling between frozen and semi-frozen states during storage and transport. The same goes for cookie pieces, brownie chunks, and caramel swirls. Each inclusion requires its own specialized formulation, created specifically to survive the extreme conditions inside ice cream production and storage. The mixing process itself represents one of the most critical phases. Industrial ice cream mixers, called continuous freezers, process thousands of liters per hour while simultaneously freezing, aerating, and homogenizing the mixture. Inside these machines, the temperature drops from 4 degrees to -5 degrees Celsius in approximately 30 seconds. During this time, sharp rotating blades scrape ice crystals off the walls faster than they can grow, creating millions of tiny ice crystals instead of large, crunchy ones. The size of these crystals determines whether ice cream feels smooth or gritty on your tongue. Factories invest millions in equipment that can create crystals measuring just 30 to 50 micrometers. Flavor science in modern ice cream production has reached extraordinary levels of sophistication. Natural vanilla, for instance, contains over 250 different flavor compounds. Replicating that complexity artificially requires blending dozens of individual chemical components in precise ratios. The flavor labs attached to major ice cream factories employ chemists who spend years perfecting single flavors, adjusting formulations based on how they'll interact with milk fats, how they'll survive freezing, and how they'll taste at different temperatures. Your tongue perceives flavors differently at -15 degrees Celsius than at room temperature, so everything gets calibrated for consumption temperature. The hardening tunnel represents another engineering marvel. After ice cream exits the continuous freezer at -5 degrees, it's still too soft for packaging and storage. It travels through blast freezing tunnels where temperatures plunge to -40 degrees Celsius, with hurricane-force winds circulating to ensure even freezing. Products spend anywhere from 30 minutes to several hours in these tunnels, depending on size and composition. The rapid freezing prevents large ice crystal formation and locks in the texture created during the initial freezing phase. Quality control in these facilities operates continuously, with automated systems checking dozens of parameters every second. Viscosity sensors ensure the mix maintains proper thickness. Density meters verify correct overrun percentages. Temperature probes monitor every stage of production. Microbiological testing happens hourly, with samples pulled from production lines and analyzed in on-site laboratories. Metal detectors and X-ray machines scan every package before it leaves the facility, capable of detecting contaminants as small as 1 millimeter. The rejection rate in top facilities runs below 0.1%, meaning fewer than 1 in 1,000 packages fails inspection. Here's a detail that surprises everyone. Ice cream factories carefully control the mineral content of their water supply. Calcium and magnesium levels affect how proteins behave during mixing and freezing. Too much mineral content and you get off flavors and texture problems. Many facilities use reverse osmosis systems to strip their water down to near pure H2O, then add back precise amounts of specific minerals. This level of control ensures consistency regardless of seasonal variations in municipal water supplies. The packaging process moves at speeds that seem impossible until you witness it firsthand. Modern filling machines can package over 400 units per minute, with robotic precision that ensures each container receives exactly the specified weight, down to the gram. Lids get applied, sealed, and date stamped in fractions of a second. Packages get sorted, boxed, and palletized without human hands touching a single container. The entire journey from liquid mix to packaged product ready for distribution takes less than 2 hours in the most advanced facilities. Sustainability has become a major focus in modern ice cream production. The refrigeration systems required to keep these facilities running consume enormous amounts of energy. Leading manufacturers have invested in heat recovery systems that capture waste heat from refrigeration compressors and use it to preheat water for cleaning and pasteurization. Some facilities have achieved 30% reductions in energy consumption through these innovations. Water recycling systems recover and treat water used in cleaning operations, reducing consumption by millions of liters annually. The storage warehouses attached to these factories maintain temperatures of -25 degrees Celsius year-round, regardless of outside weather. These massive frozen repositories can hold millions of liters of product, organized by production date and flavor. Automated retrieval systems navigate the frozen aisles, selecting products for shipment based on first-in, first-out inventory management. The logistics software managing these operations tracks every pallet, every flavor, every production batch, ensuring products reach stores with maximum remaining shelf life. The manufacturing process begins long before milk arrives at the factory. Dairy suppliers operate under strict quality protocols, with farms testing milk multiple times daily for bacteria counts, antibiotic residues, and somatic cell levels. Only milk meeting exacting standards gets approved for ice cream production. Tanker trucks equipped with refrigeration systems maintain milk at precisely 4 degrees Celsius during transport, with GPS tracking and temperature logging ensuring cold chain integrity from farm to factory. Upon arrival, each tanker undergoes immediate testing. Laboratory technicians draw samples and run rapid tests for fat content, protein levels, and bacterial contamination. The milk gets pumped into massive stainless steel silos, each holding up to 50,000 liters, where it's held at 4 degrees until production begins. These storage tanks feature automated cleaning systems that sanitize between batches using high-temperature water and food-grade chemicals, ensuring zero cross-contamination. The mixing room is where transformation begins. Precise amounts of milk, cream, sugar, and stabilizers get pumped into blend tanks according to computerized recipes. Each ingredient flows through dedicated pipelines, with flow meters measuring quantities to within 0.1% accuracy. The stabilizers, usually combinations of guar gum, carrageenan, and locust bean gum, arrive as fine powders and get hydrated in separate tanks before addition. These compounds, used in amounts less than 1% of total mix weight, provide the structure that prevents ice crystal growth during storage. Homogenization follows mixing. The blend gets forced through tiny openings under pressures exceeding 200 bar, shattering fat globules into particles measuring less than 1 micrometer. This process prevents cream from separating and creates the smooth mouthfeel associated with quality ice cream. The homogenizer operates continuously, processing thousands of liters per hour with a distinctive high-pitched whine that fills the production floor. Pasteurization happens in plate heat exchangers, where thin layers of mix flow between heated plates. The temperature rises from 4 degrees to 85 degrees in seconds, holds for exactly 15 seconds, then crashes back to 4 degrees through cooling plates on the opposite end. This thermal treatment eliminates pathogens while preserving flavor and nutritional value. The entire heat exchanger assembly gets cleaned in place after each production run using automated cleaning systems that circulate hot water and caustic solutions through every channel. The aged mix then rests in refrigerated tanks for 4 to 24 hours. This aging period allows proteins to fully hydrate and fats to crystallize in their most stable form, improving the final texture. During aging, flavors and colors get added. Liquid flavors flow through dosing pumps that add precise amounts per batch. Powder flavors get mixed in using high-shear blenders that ensure complete dispersion without clumping. The continuous freezer represents the heart of ice cream production. Mix enters at 4 degrees and exits at -5 degrees, transformed from liquid to semi-frozen ice cream in approximately 30 seconds. Inside, a rotating cylinder with scraper blades spins at high speed while refrigerant circulates through the outer jacket, dropping the cylinder wall temperature to -30 degrees. The blades scrape ice crystals off the walls thousands of times per minute, preventing large crystal formation. Simultaneously, compressed air or nitrogen gets injected through precisely calibrated nozzles, creating the overrun that gives ice cream its texture. Inclusions get added immediately after the continuous freezer through specialized feeders. Chocolate chips flow down vibrating chutes that distribute them evenly across the ice cream stream. Ribbon sauces get injected through multiple nozzles that create swirl patterns. Cookie pieces drop from hoppers at controlled rates. Nuts get added through auger feeders that prevent clumping. Each inclusion system operates independently but synchronizes with the main production line, ensuring consistent distribution throughout every package. The filling machines represent precision engineering at its finest. Ice cream flows into a manifold that splits the stream into multiple filling heads, each capable of filling containers at rates exceeding 100 per minute. Servo motors control piston movements with sub-millimeter accuracy, ensuring each container receives exactly the specified fill weight. Containers arrive on high-speed conveyors, get positioned under filling heads, filled, and moved to lidding stations in continuous motion. Vision systems inspect each filled container, rejecting any that fall outside weight specifications. Lidding happens in sealed chambers that exclude ambient air, preventing frost formation on lid surfaces. Lids get pressed onto containers with precisely controlled force, creating hermetic seals without damaging the package. Date codes and batch numbers get laser-etched onto lids as they pass inspection stations. Rejected packages get automatically diverted to rework bins where they'll be remelted and reprocessed. The hardening tunnel extends over 50 meters, with multiple zones maintaining different temperatures. Products enter at -5 degrees and exit at -18 degrees, with a temperature drop happening gradually to prevent thermal shock that could damage texture. Powerful fans circulate air at velocities exceeding 20 meters per second, ensuring even heat removal from all sides of each package. Conveyor systems carry products through the tunnel at carefully controlled speeds, with dwell time calculated based on product size and composition. Final packaging happens in climate-controlled rooms maintained at -20 degrees. Robotic case packers arrange individual packages into shipping cartons with speed and precision impossible for human workers. Cartons get sealed, labeled, and palletized by automated systems that build stable pallet loads optimized for transport. Stretch wrapping machines apply protective film around completed pallets, which then get conveyed directly into frozen storage warehouses. Throughout the entire process, cleaning and sanitation receive constant attention. Production stops periodically for clean-in-place cycles where hot water and cleaning chemicals circulate through every pipe, valve, and tank. Surfaces get sanitized using approved food-grade compounds. Microbiological swab testing verifies cleaning effectiveness before production resumes. This attention to hygiene ensures product safety while maintaining the production efficiency demanded by modern markets. You've just witnessed the hidden complexity behind something most people never think twice about. That ice cream in your freezer represents the culmination of decades of food science innovation, millions in equipment investment, and precision engineering that rivals any high-tech industry. But the world of mass-produced treats holds even more fascinating secrets. Ever wondered how donuts achieve that perfect golden exterior while maintaining a pillowy soft interior? Or how factories produce thousands of identical glazed rings per hour without a single imperfection? The manufacturing processes behind these beloved breakfast treats involve challenges and innovations that rival ice cream production in complexity and sophistication. The next video that just appeared on your screen reveals the incredible technology inside a high-tech donut factory, where dough gets precisely portioned by machines, fried at exact temperatures monitored to the degree, and glazed with robotic precision that ensures every donut gets the perfect coating. You won't believe the engineering required to create a product that tastes handmade but gets produced at industrial scale with consistency that would be impossible for human bakers to match. Make sure you're subscribed so you never miss these deep dives into the hidden world of food manufacturing. And here's a question for the comments. What surprised you most about ice cream production? Was it the air content, the crystal size control, or maybe the specialized chocolate formulation? Drop your thoughts below, and let's discuss what other factory processes you want to see explained next. The factories never stop running, the innovation never stops advancing, and there's always another fascinating production process waiting to be uncovered. See you in the next one.